go here, lunar.folger.edu, and type in Sonnets 1609, and then hit the search thing. You do not want that. That has been cropped, which is fair enough, but then they've straightened it up for some reason. It doesn't need straightening up, it's already perfect. You want that. Click on that a couple of times, and then click on export, which means download, and then click on it again because it's got a bug, and then click on supermassive, and when that's turned up, I want you to load that into GIMP and crop it to your own random size so that you don't get the same numbers as me. Right, I've now cropped that to my own size, which will be different from yours. So what I want you to do now is zoom right in and right in. Really zoom in. I want you to get this pixel exact. Right? Now on this version I've got a Y value of 1079 down there at the bottom, so I'm going to do a image guides, new guides, horizontal 1079, is that right? Yeah, 1079. And then while we're here and we're doing horizontal rules, let's just go down to this one and do another one there. So alright, that should be about there, and that's 1697. Okay, so we've got two nice horizontal rules now. Now, what I want you to do is zoom in to the beginning and the end, the be all and end all, this huge full stop next to the G, and marvel at its size, and ignore this thing that's slanted off on here. You know, we don't know what that is. No bother finding it out. So I want you to put draw a line from the centre of that. So put one there, and I've already got a position. Apparently, that's already there. So let's move that, and I want you to draw it so that it goes straight through that claw. So let's move in. I want it perfectly on that claw and on that line, and paths. Actually, I can see that afterwards. So, and I'd like you to measure the angle that you've just created there, the angle of that red line. Now, I now want you to draw a series of vertical rules. The first is just here while we're here, and at exactly the point that that hits there, that exact pixel, which is at 1990, an x coordinate, I want to have a vertical rule from there. So guides, new guides, vertical, 1990. There we go. And then I want you to draw three more. The first one, you'll see that this horizontal one goes straight through the middle of that dot, right? So there's this square dot here. I want you to draw a vertical rule from there. So that is at 2670, basically, or 2669. Image, guides, new guides, there we go. And then I want you to draw two more Right, the first one is this S, and I want you to take if you like, a white dot the same size, and imagine that you're trying to rest this S on a square dot of that same size. So it would have to go about there, and I make that at 1450. Image, guides, new guides, 1450. And then I want you to do the same at the end. Right, so where this comes out here, round about there, that is 234, 235, call it 234. Image, guides, new guides, vertical, 234. Super. So now we've got this these horizontal and vertical rules, and what I want you to do now is draw another line from here. I should just clip onto that, snap onto that, and I want you to draw it through the dad's army arrow and finish it on this line here. Right, so let's zoom in. Done pretty well there. And hopefully that will encourage you that that is an arrow pointing in this direction. It does look like it now. Yeah, that's okay. And then I want you to draw another line from here to where that intersects. So round about there, let's zoom in, where that intersects that, I think it's a little bit better than that. Right there. And make sure we can still see it. And then I want you to draw another line, actually two lines, from there, and I need it to go through that cross there, through where that intersects, and then I want you to zoom in and then extend it so that it's still going through there, but it finishes it on there, and then I want you to draw another point on it, which is right in the middle of that there. Make it visible. Right, I've just got you to draw what is actually, when you measure it, a 60-degree line, and oh, that's wrong. Oh, that's wrong. A 60-degree line and a 45-degree line. There you go. That's a 45-degree line. And a vertical line. So 90, 45, and 60. They're about as regular as you could possibly come up with. Now, we're not quite going. This blue line should be beheading him, and if you draw this using trigonometry, it will do. But I think that's to draw that freehand and get three things going through what is a monkey's head. Right? I know it looks like Homer Simpson. It's not. Matt Groening has stolen from John Dee. So, you know, I'd like you to do that and just enjoy some of the accuracy of this. Now, at this point, you can draw a golden gnomon on these vertices and then drop a transparent pentagon into that, fit a hexagon onto the bottom of it, and you can end up drawing a Vesca Piscis. I invite you to have a go at that. I want you to draw one other line on here before I show you what we've now recently discovered. And I want you to go from here, so that's the dot next to the T, the first T, and I want it to go to there, right? And just make sure it's in the middle of the T. that dot there, and it will be at the top because it's snapped on. And what I'd like you to do is then witness that you've just drawn a line that goes perfectly through that. Now the geometry defines this as a little bit to the left, so I'll try and explain to you the nuance of that. I also need to point out that that point there, which again this S is resting on, that's been derived, of course. You know, we drew this 30-degree line to go through the Dad's Army arrow, and we got this out. These three S's have all got a consistent way of defining them. They've got a very nice point in the middle of that, and I'm about to discuss that we have now solved what that point is. Now, before we leave this drawing that you've made, I just want to point out that you should have drawn that line going straight through that little dot on the bottom there. I'll look perfectly through there, and there's another blob there, and this is round about there as well. So, what's that all about? Now, I left you on the last video with this diagram, which shows these red lines that I'd discovered arrowing through the ends, and this blue line. But I told you that we these two dots here need to pressingly part of the geometry. It's this S. I need to know exactly where this S is, you see, so I know this needs solving, and these two dots are pretty blatant. And I also told you that that line there, it doesn't do just that. And again, if anything's there, it won't just be hanging off the edge, it will be multiply connected. So I bring you the third perfect golden gnomon. There's one at the bottom here where it goes along the side of the W and along the T, and this Y is deliberately pulled down, and it also goes through the O, which I didn't dare mention at the time. Well, there's a perfect golden gnomon here, and from that very point is defined as the Venus dot. It's the reflection of the line up here. It all comes from the bottom, and we're going to take the apex of the 51-degree pyramid as the base of it. When we do that, the left vertex is predicted perfectly, and the right vertex is coincidentally not just on the green line here, this comet line, but almost exactly where the blue line hits it, which is astonishing. But what's more astonishing is that there's a total of 5 different objects: the comet line, the upper gnomon, the Venus line, the Great Pyramid, and what's not shown on here because it just makes it too complicated is that the Great Triangle, and you just drawn one of those lines, goes straight through that dot as well. So that's what I call integrated. And then this one's so obvious. It's like, how could you know? But you need the vector lines, and you need all the shapes at your disposal. This one is defined as a perfect 45-degree line from the left side of the Great Pentagram. That's what it is, and that vertex is where that line cuts this green horizontal, and that just happens to be within a millimetre of where the vertex of this green equilateral delta dot triangle is. And then when I bounce it from there up in this direction, it will hit perfectly we terminate that on a horizontal that is coincident with that vertex, right? But we could be left or right of that vertex. We're bang on it. So this is connecting 3 shapes. It's connecting the green, the blue, and also the pentagram. So it's integrated. That now gives us the three right-angled equilateral triangles, and also, as I say, three golden gnomons. So isn't that fab? We've now got, I think, 11 groups of three on here. Three crosses, three novel crosses, a Petra and a Tau, and possibly a Rosicrucian, but a cross. Three equilateral triangles, three right-angle triangles, three golden gnomons, three golden triangles, three squares, three hexagons, but we've only got, etc. So I think there's 11 or 12, and then we've only got two pentagons to my liking, and I have no idea where the third one is. So that's outstanding. Of other things now, so apart from that pentagon, there's one of my outstanding issues now is I'm beginning to realise, and you probably realise I keep saying it, this is bent up, and it's done so deliberately. I don't need to move this end. This end is perfect with regard to the pentagram. But we've known for ages that at and don are they're visibly higher than lon, and they've been raised up in order to do this nonsense here, and so that their red triangle should be a little bit further up and be perfectly coincident with this bent lower rule. The thing about that is that this thing here fits the bent stuff. So what's going on? Because that doesn't fit the bent stuff. And the weird thing about that is that in order to fit the bent stuff, if you draw a perfect line from here up to there, it will go through the adjusted A. So on top of this being bent, this thing seems to be lifted up in order to compensate for that. I just wanted to rub it in on just how accurate this is. This is the two dots here, the two chocolate drips. This one here with the missing bit on the top of the S. We already knew that went through there, but yeah, the apex of the pyramid is exactly on there, on this one. So this is the corner vertex of that golden triangle, and I think that can be regarded as a bullseye. Now, this is where the other vertex, the other corner of the golden triangle ends up, and that there. So let's just zoom. I have to zoom in to see this. That there is the golden gnomon extension, and you'll see that this comet is in the wrong place because all this stuff's happening here. Why didn't it over here? Well, you've drawn a line, haven't you, that goes straight through there. So that's why that's lined up there. But the geometry, this comet line will end up just north of where the dot is. See, it ends up just up here, and that's actually where we're currently landing on. I'm predicting that line to be slightly lower. And so here is the right-angled equilateral triangle, right-angled isosceles triangle at the bottom. And I mean, let's just pull out a little bit, and it's like, well, sort of they're the same, surely, but they're not. Right, so that's how near. That's our apex of that's where the 45-degree line comes in. It doesn't hit that vertex, but it's so close. And then as we go up here again, you'll see that there's a little bit of stuff going on there because that's not quite there, but it's pretty damn close. And actually, that circle that's being derived, hasn't actually come out. So that just shows you what level of resolution we're working at here. The trigs stop working. I should point out that this Aspley here, which we now have the triangle on the bottom, I now know that this is about a millimetre. The whole thing is a millimetre out But yeah, I'd been lying to you, and I swear it's the only one that I had done. But the 30, 60, 90 Kepler triangle wasn't a perfect one. It now is. And as a result, it will overshoot this circle by a millimetre, but that's fine. I mean, that's what it's supposed to do. But that means that the swoop dot, the kink, the gap, and the apex are all about a millimetre to the left of where they should be. Arguably, it should be a smidgen down as well. So, right now, one of the things we were looking at here in these red lines at the top was where they point to, and this one appears to be pointing to the gap in the K. This one is a little bit problematic. I mean, I've drawn the 45-degree line that's from the Vesica Piscis, but this isn't really exactly at 45 degrees, and you can point it further up there. So I'm not sure if there's something going on here as well. This one is, I think, noticeably very well in line, and 49 degrees does work perfectly for this. I'm not sure if it's supposed to try and clip the eye. It's not really going through the eye, but no, that's not how I would normally like it. And so it goes. It's defined as going through that point, but that point, which is the same point of the A, which is used on this A and also on the Aspley swoop. This line carries on up, and it does appear to go to a tiny dot there. Whilst that is a very tiny dot, it's still bigger than other dots on there. And if that is a dot, if that's a star, then this 49 degrees can only be one thing. It can only be Alcade, which is the last of the three mourning maidens which form the tail of the Great Bear. And I've no idea, other than that De Vere died with three daughters, what Alcide, what link that has. And currently, as you can see with these two blues, I'm of the idea that the two pillars, Boaz and Yakin, I've coloured in blue, and we've got a perfect golden triangle A in the middle. The rest is up to you. I put this on because I'm trying to work out what role this square has in the Vesica Piscis. This is the square of the Vesica Piscis. So I was trying to look at what this is supposed to be. It may be intended to refer to the temple, according to one piece of nonsense that I was reading. So that's your lot. Both of these concluding elements, they further corroborate, the whole model. We've got the three right-angled isosceles. The third of the golden triangles is this A. And we've just got a pentagon somewhere on there to find. And I've got the nuances like this lower rule, there really surely can't be much left other than arguing about Hiram Abiff. Now, while I'm here, I was just checking on this because I've noticed it before, but there are 40 notches across the bottom here and 17 on each of these diagonals, and that's a fairly trivial find, but it wasn't in the presentation that I saw. So if nobody's seen that before, I am going there soon, and I'm going to have a damn good look at all of these ridges and take some photographs. There is nothing at all on that monument that wasn't put there for a reason.